China lands an Orbital-Class booster for the first time, finally catching up to SpaceX and Blue Origin, NASA's next Artemis mission begins stacking, Europe's space industry had a big week with new launch contracts and rocket debuts getting closer, space debris washes ashore in Australia, and Starship's next flight may be just around the corner. All that and more coming up this week in Spaceflight. It's another week, which means we have even more updates from Blue Origin on the reconstruction of Launch Complex 36, among other Blue-related news, but let's start with that first. If you've watched our most recent Space Coast update episode, and if not, there should probably be a link in the description somewhere, then you may have seen that the company is making great progress towards clearing out the pad, but there were still a few big pieces of equipment left to remove. In particular, the launch bridge, a large concrete platform that sat over the flame trench to support the launch mount that, after the explosion, broke free and fell into the trench. According to CEO Dave Limp, this launch bridge weighs almost 4 million pounds, or almost 1,800 metric tons, so 2 large cranes were needed to lift it out of the trench and onto self-propelled modular transporters. According to Limp, this launch bridge and the launch mount, which was also thrown into the trench, are still in good enough condition to be reused. Let's just say it's a bit curious how easy they're finding all of this to be repaired and reused again for launch, given the extent of New Glenn's explosion. But as always, time will tell whether it will all work out or not. As Blue Origin gets ready for New Glenn's return to flight, they're also preparing for the first flight of the company's Blue Moon lander. That first Blue Moon lander, called Endurance, recently underwent fit checks with the BE-7 engine that it'll use for its main propulsion. According to the company, this was done to fit, trim, and weld the feed lines for liquid oxygen and liquid hydrogen, and to adjust the struts to installation length. These feed lines, as the name indicates, are the pipes that feed the oxygen and hydrogen into the engine. What the picture also shows is that the engine gets mounted to the bottom of the lander's liquid hydrogen tank and is then surrounded by the 4 liquid oxygen tanks on the lander, one of which is clearly not installed in this image. The lunar lander uses the BE-7 engine for main propulsion, but it uses a separate set of thrusters for attitude control. A few years ago, Blue Origin showed progress on a set of thrusters powered by gaseous oxygen and hydrogen for their Blue Moon landers. This week, they showed testing of a different kind of thruster running on hypergolic propellants, which the company dubs BT-7. I guess that stands for Blue Thruster 7, just how BE-7 stands for Blue Engine 7. What's interesting is that the company's post suggested this new hypergolic thruster is the kind that Blue will be using for the Blue Moon lander on the upcoming Artemis III mission and future lunar vehicles. So in other words, for some reason, Blue Origin is apparently getting rid of the old hydrogen-fueled thrusters. Those were meant to be more efficient, both because hydrogen as a fuel is more efficient, and also because it meant not needing a separate set of propellant tanks for the thrusters. So it is a rather intriguing change, given that this is the only time the company has publicly talked about this change in design, and it's not a small one. It also begs the question of why the change to a less efficient system this late in development. Now let's check in with the companies participating in the European Space Agency's project to develop next-generation rockets dubbed the European Launcher Challenge. Recently, they lost one competitor after Orbex went belly up, but there are still 4 companies left in the race, and we've got some news on all of them. Let's start with Germany's Isar Aerospace, which secured a launch contract with the German branch of Planet Labs, the Earth observation company. Planet's building a factory in Berlin where they'll build Pelican satellites. That's the name of their next-generation platform. The new plant will complement the company's headquarters in San Francisco, which is currently producing the Pelicans. Once started up, the production line in Berlin will double Planet's production capacity. It should be coming online fairly soon, as the Pelican satellite Isar will launch will come out of Berlin, and it's set to launch within 12 months from signing the agreement earlier this month. The companies say that this will mark the first satellite launch where both the payload and the launch vehicle are built in Germany. Not everything about this mission will be German, though, as it will lift off from Isar's launch pad at Norway's spaceport in Andøya, where they also launched their first Spectrum rocket and are now trying to get the second off the ground. Soon, Isar will also start working on another spaceport on the other side of the Atlantic. This week, the company signed a contract with Canada's Maritime Launch Services to develop dedicated launch facilities at Spaceport Nova Scotia. Isar has set up a Canadian subsidiary to make it happen. But why Canada? Well, the changing geopolitical landscape means that countries are increasingly looking for sovereign launch capability. Isar is vertically integrated, so they control every part of the rocket production and launch, and as a result, they can offer launch capability as a single party. That said, there may be a few different reasons why Isar is going to Canada now, as the deal seems to be linked to another major contract awarded to a German company this week. But for that, we'll need to go down where it's wetter, as this week submarine builder TKMS was awarded a contract to build 12 submarines for the Canadian Patrol Submarine Project. Now, what does that have to do with rocket launches? In May, TKMS announced a partnership with Isar to build sovereign Canadian launch infrastructure in Nova Scotia. It certainly seems like they might have thrown in a launch pad to sweeten the submarine deal. We can't say for sure, though, as neither company mentioned the deal in their press statements about the recent contracts. Either way, they're planning to start moving with it very soon. Isar intends to begin building the launch site later this year, with the first orbital launches targeting 2028. The pad would then support ramping up to as many as 40 launches per year by 2029. Now, we'd love to see that happen, but it sounds unlikely. Don't get me wrong, we love ambitious space companies here, but Isar has yet to get anywhere near space. They've been trying to get their second mission to lift off since last year, which feels like forever now, and they need to get it going quickly and then ramp up at unprecedented pace if they want to conduct dozens of Spectrum launches from Canada in just 3 years. In Isar's defense, they didn't say that they're targeting that cadence, only that the pad will support it. They've got a 10-year term on the agreement with renewal options for up to 20 years total, so that seems like long enough to make it happen, and we'd love to see it. But let's get that second Spectrum off the ground first, please. Speaking of upcoming launches, the other German contestant in the European Launcher Challenge might attempt its first launch next month. This week, the Saxavord spaceport announced that a 5-week launch window will open on August 10th. Who's launching? Well, the only ones with a pad out there are rocket Factory Augsburg. RFA has been getting ready for its first flight for a long time, but it wasn't smooth sailing all the way. In August of 2024, a first stage test of RFA-1 ended in a big fireball at Saxavord, and although most of the launch pad came out unscathed, it did substantially set back the program. But now RFA is back with a new and improved rocket out at the pad, apparently ready to try out a launch soon. Although the launch window lasts 5 weeks, the actual slots available for launch are limited to Mondays, Wednesdays, and Fridays between 4 p.m. and 8 p.m. Saxavord says that this is to minimize disruptions for the neighbors and maintain safety standards. They'll announce decisions to attempt a launch 24 hours in advance, so residents can get a heads up and some time to plan. Although Saxavord is very remotely situated in the Shetland Islands, so 24 hours might actually be too short notice to get there in time for the liftoff. Assuming, of course, that the launch doesn't delay or scrub for weather or technical reasons or any other factor that might get in the way. So, should you expect RFA-1 to lift off on August 10th? Probably not. It's the company's first launch, and historically, those aren't known for being very punctual. What's more, it's also the spaceport's first launch, so anything can happen, really. Now that said, they've had a lot of time to get all their ducks in a row and make sure that everything's ready for action on launch day, so who knows? What we can predict is what will happen if you hit the subscribe button. We'll update you about everything that's going on in space and send you live launch views. You don't want to miss out. After 2 German companies will move over to neighboring France, where global satellite company Loft Orbital has contracted MaiaSpace to launch multiple missions. MaiaSpace has been around since 2022 and wants to be the first European company to operate a reusable launcher. To do this, they've designed their rocket named Maia to incorporate existing European hardware. For example, the rocket's 2 stages are propelled by the reusable methane-powered Prometheus engine developed by Maia's parent company, Ariane Group. 3 of them are fitted on the first stage and 1 on the second. Maia has an optional 3rd stage called Kolibri, developed by Poland's Łukasiewicz Institute of Aviation. Flying in its expendable configuration, Maia can launch up to 4,000 kilograms into low Earth orbit. Although last month, European Spaceflight reported that the company plans to add a 4th Prometheus engine to the first stage, which would double the launch capacity. Maia is set to debut early next year, flying from Europe's spaceport in French Guiana, where the company has leased the pad that was previously used for Soyuz missions. For its new contract, Maia will loft European satellite missions into orbit. Operating since 2017, Loft Orbital provides a standardized satellite platform upon which customers can install their payloads. Loft has secured multiple missions from MaiaSpace, the first of which may launch as soon as 2028. Crossing a border to the south, there's one more player in the European Launcher Challenge, Spain's PLD Space. The company is working on a small-sat launcher called Miura 5, which they intend to fly for the first time later this year. To get to this milestone, PLD has churned out a lot of rocket hardware in recent months, leading up to the production of the first flight hardware. All these components, including 2 full qualification models, will undergo exhaustive testing to ensure that the first flight goes as smoothly as possible. Recently, the first fully completed Miura 5 second stage left PLD's factory. It's outfitted with everything it needs to operate in space, including avionics, a propellant feed system, and the reaction control systems that it'll use to move around in space. The next stop for the stage will be EMC testing, or electromagnetic capability testing, which verifies that the electronic systems won't interfere with each other, or the communication systems of other satellites for that matter. PLD says that the stage will travel abroad for this testing, although they didn't specify exactly where. After the EMC test campaign, the stage will make its way back to PLD's facilities, where it'll receive its engine, which PLD plans to test with a static fire campaign at its test site in Teruel. Unfortunately, we haven't heard from PLD about Miura 5's first stage in a while. We hope it's well underway and still tracking for launch this year, but we wouldn't mind an update. Please? Either way, there's a lot going on in Europe, and the next few years promise some very exciting launches. And maybe even some landings too, as all of the companies that we discussed today have a roadmap for reusability, which we cover in our Europe's Future in Space livestream series, where we've interviewed people at a number of these companies. We're glad to see some movement in Europe's space industry, and we can't wait to share where it's going next. Starship's last flight was about a month and a half ago, and we may now be under a week away from the next one. This week, SpaceX rolled out the next super heavy booster, Booster 20, out to Starbase's Pad 2. This is the same booster slated to fly on Starship's 13th flight. This is all part of the vehicle's routine test campaign as it prepares for launch. It previously carried out a cryogenic proof test campaign in early June, then went back to Starbase's production site for engine installation. The interesting thing is that this engine test campaign may be occurring less than a week away from launch. Just a few days ago, notices started to appear for Starship's 13th launch, indicating that it could happen as soon as July 15th in the late afternoon local time. The flight profile also seems to be similar to the last flight, as expected, with the rocket heading southeast, flying between Cuba and the Yucatan Peninsula, with the ship eventually splashing down in the Indian Ocean. When Booster 20 rolled out to the pad, it looked much more complete than its predecessor, Booster 19, when it was at the same step in the pre-launch flow, so it might not be that unrealistic for it to be close to or completely flight ready once engine testing is complete. And now to Ryan for some late-breaking news.
That engine testing was successfully completed this morning before 10 o'clock local time. Talk about a good start to the day. Most, if not all, of the 33 Raptor 3 engines were ignited for a static fire, which was approximately 25 seconds long. This is the longest super heavy static fire SpaceX has ever conducted, thanks to the new beefy launch mount design at Pad 2. We'll cover the build-up to flight in our next Starship update on Monday, and of course we'll have our countdown to launch chat shows as well. I'll be back later to talk about China's booster catch, but for now, back to Alicia.
Now, if all goes well with Starship's 13th flight, and the 14th, and the 15th, and so on, it'll also eventually go on flights to the moon, not only because of NASA's Artemis program, but because the company has its own moon plans. In fact, there are a few companies out there helping NASA with the Artemis program, while also having their own interests in the moon. One of them is iSpace, a private Japanese company which has attempted to land on the moon twice with its Hokuto R lander. While it's not yet seen success, it has come close, and is hoping in the future to finally ace that landing. The company has a subsidiary in the United States, which already has a lunar lander contract with NASA, so they are committed to it. But what does all of this have to do with Starship? Well, out of the blue, this week iSpace announced that it's jumping on the train of being a payload aggregator, but not for a low Earth orbit rideshare mission like Transporter, but rather for a lunar landing mission on SpaceX's Starship. The company says that it has secured up to 500 kilograms of payload capacity on Starship to be launched no earlier than 2030. Not only that, they say that they'll use their own new platform called Mobile Cargo System, where the payloads will be integrated for deployment by Starship on the lunar surface. The company says that this service, rather than replacing its own lunar lander program, will instead be an addition that the company will offer to customers to open up access to the lunar surface. iSpace is planning an additional 3 lunar landings in 2028, 29, and 30, one per year with its lander. So it would seem like another way for the company to gather extra revenue from customers without really having to create the lander themselves right now, while also leveraging the experience of having previously supported payload integration for lunar missions. Believe it or not, there's even more space news. So now let's take a look at some other things that happened across space this week, starting with Artemis. It feels like we've just recovered from Artemis II, but NASA's already going full steam ahead with the missions beyond. The agency doesn't want to wait around, and it plans to launch the next Artemis mission, Artemis III, next year to increase the launch cadence of the SLS rocket that will carry the Artemis crews up into space. And the rocket for that next mission will start taking shape very soon. Several parts have arrived at the vehicle assembly building at the Kennedy Space Center, where the agency is already assembling the rocket's core stage. But now, the first solid rocket booster sections have also found their way into the VAB. Soon, engineers will start stacking them onto the mobile launcher, which really marks the start of SLS assembly. So I guess we're now officially counting down towards the next mission of NASA's lunar exploration program, even if it's a demonstration flight that won't leave low Earth orbit. It'll still be an important test for the agency and its partners, though, and it will certainly help them to prepare to land on the moon with Artemis IV. And speaking of, NASA just released some images and video of the liquid oxygen tank for the Artemis IV SLS. This massive tank will be part of the rocket's core stage and hold over 740,000 liters of liquid oxygen to propel the astronauts on their way to our celestial companion. The whole thing has now moved to the main rocket factory, where SLS contractor Boeing will inspect it and install internal baffles, and eventually integrate it with the rest of the rocket. While we love seeing the rocket that will carry the next humans to set foot on the moon take shape, there's something we don't understand about NASA's announcement this week. That whole operation of moving this tank, well, it happened nearly a month ago. It might just be a tank, but it is still a major step towards that big mission that everyone's looking forward to. So with all the hype generated by Artemis II, we kind of hope that NASA would be a bit more on top of these releases, but oh well. And speaking of Artemis II, we also got some news from mission specialist Jeremy Hansen this week, whose first spaceflight was definitely one for the books. Most astronauts don't get to see the moon up close during their very first spaceflight, but he sure did. It now seems that it may also have been his last flight, as Hansen announced that he'll retire from the Canadian Space Agency in September after a 17-year astronaut career. But that doesn't mean that we won't hear from him again. He'll now transition into a reservist role at the Royal Canadian Air Force, which in his tweet he described as, quote, a deliberate launch pad designed to leave the door open for creative, ongoing ways to support and enable the vital work happening in Canada with respect to space. I guess we'll have to see what that will look like, but like many other retired astronauts, he could end up at one of many space companies. And some of those also send astronauts up into space, so there's always a chance that he might get to log even more hours in space beyond Artemis II. Either way, thank you, Jeremy, for inspiring us all during your trip to the moon, and we're excited to see what's to come, eh? Our next spaceflight story is about metal balls washing ashore on Australian beaches. I promise it's really not as weird as it sounds. Earlier this week, these objects appeared on a beach down under, and they look like some kind of pressure vessel. The Australian Space Agency got involved and says that it has identified them as debris from a foreign rocket that recently re-entered from orbit. Now, ideally, we wouldn't have debris like this make it all the way back to Earth. Rocket builders and satellite operators increasingly are designing their vehicles to fully disintegrate upon re-entry, unless of course they're meant to be reusable. But there's still a lot of old hardware orbiting our planet, and some countries like China still operate rockets that come back in large chunks. So this won't be the last time that random rocket parts show up somewhere unannounced. And by the way, if you ever do encounter some, don't go near it. We all love to see rocket hardware up close, but you're probably better off running away from it. Tanks like these might contain highly toxic hypergolic propellants, which you definitely don't want to breathe in, and there are many other materials used in spaceflight that you might not want to get too close to without protection. So stay safe out there, you guys. The U.S. Space Force has added 2 more companies to its NSSL Phase 3 Lane 1 contract this week. Now, what on earth does all of that mean? NSSL stands for National Security Space Launch, and through that program, the Space Force selects launch providers for its missions. It's currently in its third phase, which consists of 2 lanes. Lane 1 is for low-risk missions, and Lane 2 is for high-risk missions and is subject to much stricter requirements. Falcon 9, Vulcan, and New Glenn are part of both lanes, and Rocket Lab's Neutron and Stokes Nova are only in Lane 1, which makes sense considering neither vehicle has flown yet. This week, the Space Force added Relativity Space to Lane 1 with its Terran R rocket, alongside Impulse Space with its Helios kick stage, meaning both companies are now eligible to bid for national security missions. The latter is certainly an interesting pick because Impulse doesn't have a rocket of its own, only an upper stage, as the company considers itself an in-space logistics provider. With that, Impulse is now the first upper stage provider selected as an NSSL prime contractor. In practice, this probably means that Impulse has to subcontract launches from other NSSL providers for its national security missions. But either way, congrats to Relativity and Impulse, who now get to bid for some of these high-profile Space Force contracts. That's a big deal. While some of those military launches may appear on future space traffic reports, now it's time for this week's traffic report, powered by Next Spaceflight. Let's start in deep space and Hayabusa 2's flyby of asteroid Torofune. Now that asteroid's name might not sound too familiar, and I don't blame you, it is just another one of the millions of asteroids in the solar system. But it's one that just so happened to be on the path of Hayabusa 2 as it makes its way to another much smaller asteroid, known only by its discovery name of 1998 KY26. Hayabusa 2's primary mission was to visit asteroid Yugu, study it, take some samples, and return them back to Earth. That primary mission was successfully completed in December of 2020 with the return of the asteroid sample capsule, but the main spacecraft just flew past Earth. Instead of turning it off, JAXA, the Japanese space agency, decided to continue using the spacecraft and its remaining fuel to visit KY26. This asteroid is a small one, like really small, only 10 meters across, which means it's almost the same size as the Hayabusa 2 spacecraft itself. Because of its size, getting to it is also hard. It's almost like performing a rendezvous with the ISS. This in turn means that Hayabusa 2 will need multiple gravity assists from Earth, and along this intricate path to get to KY26, asteroid Torofune happened to be right in the way. This fast flyby of the asteroid was brief, but it gave us a look at yet another space rock right above us, revealing that it's another contact binary. We've seen these types of objects in multiple places across the solar system, like 67P Churyumov-Gerasimenko, or Arrokoth, so finding another one is not hugely surprising, but it's nonetheless a curious find. Coming back to Earth, this week we had quite a bit of launch activity. SpaceX launched 81 different payloads on the company's latest transporter mission, Transporter 17. These launches often contain dozens of Earth observation satellites, communication satellites, or satellites with experimental technology on them. This one, for example, carried an experimental CubeSat powered by nuclear power. Now, this doesn't mean that the CubeSat has a nuclear reactor or anything like that. Instead, it carries tritium, a radioactive isotope of hydrogen which naturally emits electrons as it decays into helium-3. These electrons can then be used to charge batteries and power electronics, like this CubeSat. Now, using tritium in itself isn't even the groundbreaking part of the experiment, rather it's the way that the tritium is packed, which could substantially increase its power density for future space applications. Aside from the transporter launch, we also had 4 internet satellite launches worldwide, 2 by SpaceX and 2 by China. The 2 SpaceX launches carried 58 Starlink V2 mini satellites, while the 2 Chinese launches carried 38 Qianfan satellites. And now to Ryan for some late-breaking news.
Hi, me again. These Changzheng launches were not the only launches from China this week. A third launch occurred this morning with the debut flight of the Chang Zheng 10B rocket, and what a flight it was. The mission accomplished several milestones, but the most outstanding was the rocket's successful booster landing and recovery, the very first time this has been done by a non-American vehicle. The Chang Zheng 10B is a partially reusable 2-stage rocket which can carry about 16 metric tons to low Earth orbit when recovering the first stage, similar to Falcon 9's performance. The first stage uses 7 YF100K engines which use kerosene as fuel and run on an oxygen-rich staged combustion cycle. This first stage is also the exact same stage that will be used for the Chang Zheng 10A, which is slated to launch the low Earth orbit version of China's next-generation cruise spacecraft, Mengzhou. Now, if you're confused and you're not sure why there's a 10A and a 10B, well, the main difference is that the 10A has a kerosene-fueled upper stage, while the 10B has a methane-fueled upper stage. The 10B is also being marketed as a commercial version of the overall Chang Zheng 10 design to be used for mass deployment of satellite constellations and other similar applications. The rabbit hole goes even deeper though, as 3 modified versions of this rocket's booster will be used for the tri-core Chang Zheng 10, no suffix on that one. That'll launch China's initial moon missions, carrying the lunar version of the Mengzhou spacecraft and the Lianyue crew lunar lander. And if that's not enough, there's also a Chang Zheng 10C variant, probably flying next year, which will be an all-methane version of the 10B. We're going to have so much fun keeping track of all of this. The recovery method is sort of a hybrid between a drone ship landing and a catch. The big truss structure has an arrestor system with wires that close around the booster as it descends. This means the booster doesn't have to carry big, heavy landing gear. It's a very unique system developed by the Chinese. It's not a copy or a rip-off of SpaceX or Blue Origin. The fact that this rocket worked both on ascent and recovery is a big deal, as it proves all this technology. The first stage could in theory be interchanged between the 10A and 10B, so that removes some uncertainty from the development of the Chang Zheng 10A. The same goes for the bigger moon rocket, since it uses similar technology. Its partial reusability will probably increase the cadence of those Tianfen and Guowang internet satellite launches we often talk about. According to state media, the plan is to carry out the first booster reuse before the end of the year, so we should expect more flights like this really soon. It's also not the only reusable rocket being developed in China right now, so while this one is the first, it certainly won't be the last. Alicia, back to you.
And going into next week, we should see a lot more activity with up to 4 Falcon 9 flights on the schedule. One of those should be the second launch as part of the Tranche 1 transport layer of the Space Development Agency's proliferated warfighter space architecture constellation. Yeah, I know that is a mouthful. From China, we should have at least 2 launches, including the 3rd flight of Orion Space's Gravity 1 rocket. Yes, the one that looks like it was taken straight out of Kerbal space program. From India, we may have the launch of the country's first commercial orbital rocket, the Vikram 1, developed by Skyroot. Also next week, we'll have the launch of the next Soyuz spacecraft, Soyuz MS-29, to the International Space Station. On board will be Roscosmos cosmonauts Pyotr Dubrov and Anna Kikina, both on their 2nd flight to the station, along with NASA astronaut Anil Menon, who will be flying into space for the first time. And if all goes well with Starship, maybe we will also have Starship Flight 13 next week, which we talked about earlier in the episode. As with previous Starship flights, expect a full range of coverage for that flight, and don't be surprised if schedules slip. We often recommend going to nextspaceflight.com or downloading the app on your phone so you can keep track of upcoming launches. And an extra tip, if you have the app, you can also set up dedicated notifications for a specific launch by going to that launch and tapping the bell on the top right corner of the screen. And that's your weekly update of spaceflight news. I'm Alicia Siegel for NSF, and we'll see you all again next week to recap this week in spaceflight.